Hello, my name is Liam Barber. I am currently completing a Bachelor of Clinical Exercise Physiology at the University of New England. I am completing this presentation as part of my assignment for EXSC 335 Motor Control and Human Development, which is coordinated by Dr. Dominic McNeil. The topic of my presentation is based upon the laboratory activity relating to the effects of fatigue on physical performance. The influence of fatigue on an individual's ability to function has been quite thoroughly investigated over a long period of time. Fatigue may be split into two large categories: central and peripheral fatigue. Central fatigue traditionally refers to a more cognitive form of fatigue. This may be associated with such factors as boredom with a task. Conversely, peripheral fatigue traditionally refers more so to fatigue in the peripheral body tissues. For the purpose of this study, peripheral fatigue is referring to specifically muscular fatigue. In general, there is a fairly colloquially known understanding that fatigue causes an individual to experience a decline in performance. However, research on the topic is not always uniform, and there are differing theories on exactly how fatigue influences performance. Muscular fatigue is often investigated in terms of skill performance. The aim of this study is to investigate the influence of muscular fatigue on a skill-based task performance. The participants were divided into two random groups. One group undertook the fatigue trials. These trials consisted of 10 rounds of 10 attempts to throw a beanbag onto a target 5 meters away, from which the number of successful throws were recorded as a score out of 10. Between each round, the participants underwent a step-up exercise with the aim to complete as many as possible in 130 seconds. The other group completed the rested trials, which consisted of the same beanbag throwing activity, but without the step-up exercise between each round. The groups then had a 5-minute rest before swapping trials, so that the rested group underwent the fatigue trials and vice versa. Throw-in scores and number of steps were recorded throughout the experiment. The results acquired from this investigation make it difficult to form any complete conclusions. The results were analysed based on the change between the first and the 10th trial for both task score and, for the fatigue trials, the number of steps taken during the fatigue-inducing activity, which was the step-up exercise. Contrary to what may have been expected, there is little evidence of performance detriment across any of the trials. Taking the average number of steps in the fatigue trials, the group that rested first suffered only a drop of 6 steps between the first and the 10th trial. The group that performed the fatigue trials first in fact experienced an improvement of 5 in the number of steps between the first and 10th trials. Neither of these changes are significant. However, what may have been expected is a noticeable decrease in the number of steps taken, which may have indicated fatigue. The lack of this decrease may indicate that the fatiguing activity was not of a high enough intensity to elicit an ideal level of fatigue, and this should be investigated in the future. In conjunction with this result, the score in the skill-based task did not suffer a decrease in performance. In fact, the minor improvement may have indicated a degree of learning from the participants. However, this change is also insignificant, and as such, no solid conclusion may be made from it. The only other area assessed is how the groups reacted to performing either rested or fatigued trials first. There is a small increase in task performance in whatever trial was completed second. This again may suggest a level of improvement due to learning. However, these results suggest little that may be viewed as significant findings in terms of how fatigue influenced the skill-based task. There may be several reasons why these results produced little in the way of conclusive information, compared to other sources that have found results suggesting a number of different ways fatigue influences physical performance. There are some limitations that may have promoted insignificant data. These include such methodological decisions, such as choosing an upper body dominant skill-based task while conversely a fatiguing exercise that is lower body dominant. Perhaps local muscular fatigue relevant to the task would have increased the influence of fatigue. As mentioned above, the intensity level of the fatiguing exercise may have also impaired the development of fatigue if it was too low. If focusing solely on the results of this study, it must be suggested that fatigue makes no significant change to performance in either a positive or a negative way. However, it would be remiss not to compare these results to the other literature on the research topic. Firstly, there is an endless amount of anecdotal evidence that suggests muscular fatigue significantly influences physical performance negatively, particularly in sporting performance. Although this very popularly supported and seemingly observable incidence appears to be correct most of the time informally, there is research suggesting that the truth of the topic is more complicated than simply that fatigue decreases performance. There is research, such as the work of Paradis, Larkin, and O'Connor, that suggests there may be an ideal level of fatigue to promote performance, similar to theories surrounding how arousal influences performance. An inverted U model is suggested due to evidence that physical exertion does not negatively influence decision making. It is important, however, to notice that performance may refer to a number of different factors. While there is evidence that decision making isn't negatively influenced, research such as that of Howard, Luce, Corley, and Johnson III suggests that muscular fatigue decreases skill-based performances such as balance, which may have further influence on athlete injury. The aforementioned study investigated a very relevant topic in terms of how fatigue influences performance. In investigating the way fatigue negatively influences an individual's balance, it explores the potential issue that high levels of fatigue may promote injury. There are several research papers that investigate the ways in which fatigue may influence the risk of injury, particularly in sporting performance. This topic has far-reaching implications for both sport and exercise in terms of reducing the risk of injury. Investigations such as that of Dees de Croix, Prestley, Lloyd, and Oliver suggest that sport-specific fatigue that accumulates may increase the risk of injury in an athlete. It is important to remember that when assessing overall sporting and exercise fatigue, it rarely pertains to only central or peripheral fatigue, and is rather a combination of both. For example, in the paper I just referred to, the increased risk of injury is attributed to interference with neuromuscular feedback mechanisms, which involves both muscular and cognitive functions. Understanding that increased levels of fatigue may contribute to increased risk of injury is key for developing ideal exercise programs to ensure that enough recovery is included. A lack of recovery sessions in training for athletes or casual exercises may lead to injuries that will negatively influence not only performance but health and well-being. A more performance-specific implication from fatigue is purely a reduced overall performance level. Most research suggests that fatigue reduces performance. However, the way in which it is reduced may vary depending on activity. Botonis, Tebekis, Terriz, Galadaz, and Platnow found that the fatigue built up during a water polo match negatively influenced performance in a skill-based task, such as shooting accuracy, as well as other physical performance measures, such as hand grip strength, repeated sprint ability, and aerobic performance. Interestingly, there was insignificant change in some physiological measures, such as blood lactate levels. This is interesting because it suggests that blood lactate being used to judge exertion, and as such fatigue, failed to correlate with the reduction of performance. Evidence that fatigue decreases performance in a number of aspects varies in degree based on the requirements of the sport, as well as what aspect of performance is being assessed. Understanding this is important for realizing that decreased levels of fatigue may promote improved performance. As such, athletes should aim to not be suffering from heightened levels of fatigue to achieve ideal performance levels. In conjunction, Coaches should realize that allowing athletes to become fatigued may reduce performance, which is relevant for training planning as well as use of interchanges in team sports. In conclusion, this particular study failed to find any significant data to suggest that fatigue influences skill-based task performance. While it failed to find anything of note, there is a large number of papers on investigations that found interesting results that appear to mostly support the idea that high fatigue levels will lead to a decrease in performance. Thank you.